This week, I thought we could cover solubility and solutions and precipitation. Uh, these are reoccurring. Oh my God, it opened up chromosomes as well. Just a minute. So solubility is plays a very important role. Have
I can't see your screen if you're sharing something.
just a minute. It should get there. It should get there. Okay, it is getting there. It is getting there. It has H2O pluses and
Yeah, okay.
H2Os and the whole nine yards. Have you ever prepped yourself any kind of drink for the gym or anything of the sort? Have you ever done that? Let's say, have you ever dissolved protein or have you ever dissolved creatine?
Magnesium only.
Magnesium, anyways, solubility depends on several factors. Have you noticed?
Yes.
What are these factors?
Solubility. Density, maybe, relative to the solution it's in.
Yes, yes.
Temperature.
Temperature, powerful factor, especially in the case of solids and
Mm-hmm.
gases between one another. Yes. What
Mm,
else?
polarity.
Polarity, extremely good. Yes, yes. This means that similar things are going to dissolve in
Similar.
similar things.
Yes.
Yeah. Why is it that when, let's say, a fat guy in a white shirt is clumsy and he has stains on his white shirt, why don't those stains wash out with water alone?
Because of their because they are the stains are probably hydrophobic.
They are indeed hydrophobic. And how can you remove them quickly?
Um,
Now, I'm genuinely curious. This is not a professional question.
using the stain remover from them.
There we are. There we are. Powerful. Yeah. In Hungary, they don't have it because they suck. But we
Uh-huh.
have Allegro, and that's Polish, and the Poles, they know how to do business. God bless their souls, and they have to have it there.
They
But it's
don't have
interesting.
them in Hungary. I
They
never.
have the in Hungary. They have these magnesium potassium sticks. I get a pack and usually I give it to people and they report sleeping better, feeling better, everything better, and I'm happy that they do feel better. I have a technician with a heart condition. She's amazing. She's like a plus one grandma. She's a delight. She's like your fairy godmother without any exaggerations. Intelligent, wonderful, caring. And because she has arrhythmia, sometimes her potassium and magnesium levels drop, and you just give her one packet and she's back to normal. But they don't have these pens. I mean, I asked the lady and she said they don't have it, but I'm not sure if she wasn't just tired to look. I don't know. It could be. It could
Uh-huh.
be because last time I asked for magnesium, potassium packets, and they just don't know because not a lot of people use these. They have no idea.
Hmm.
But yes, the remarkable thing about those pens is that they have mild oxidizing agents, and basically they just oxidize the whole thing.
Hmm.
Yeah, my mom used to have a solution called Nufer, but that reacts with the whole thing. It
Hmm.
doesn't remove the stain, it just eats it up,
Okay.
which is wonderful, which is wonderful. But in the case of dry cleaning, as you said, because of hydrophobicity,
Hmm.
organic solvent removes organic stain, everything else remains in place.
Okay.
Uh, providing the shirt is made up of silk or it's made up of a natural fiber. Because if it's made of some kind of organic polymer, well, it's really easy to dissolve the whole thing and just end up with a puddle.
Hmm.
Yeah. Oh, once one of my colleagues, he had a stain on his silk shirt, a wonderful silk shirt,
Hmm.
kind of like the one you may see on a Persian F-boy, if you know what I mean. Uh, and he soaked it in water
Hmm.
with detergent that had enzymes in it.
Okay.
The next morning, we were able to filter out the buttons and nothing else. Because silk is a polyamide.
Uh-huh.
and the enzyme ate away the amide bonds.
Oh. Hmm.
So the whole shirt dissolved completely. The stain was removed, but
Uh,
so was the shirt.
uh,
If I wouldn't have seen it with my own eyes, I would have not believed it. Now, from a physiological, by the way, when you studied chemistry, everybody's going to ask you how to remove stains from their clothing or what to do with their furniture.
uh-huh. Okay.
Yeah, my
I'll
dad
keep
is
that in
really good
mind.
with the furniture stuff. Yeah, yeah, that's specialty is furniture. He's a furniture chemist. It's really rare. There's like five of them in the entire Carpathian Basin who are specialists in the field. Yeah.
Uh,
But yeah, it never hurts. And once they know that you know this, well, that's what's going to happen. But if they know that you're a medical doctor, oh my God, or even if you have a PhD and then doctor is doctor, people are going to tell you things. I had to listen to a woman telling me about her menopause because I said I was a PhD student, and in Hungarian. Well, what's that? Well, I'm going to have a doctor's. Oh, okay. She sat down and laid it on me. Do you think I was interested? No.
no.
Did I listen? Yes. Did she feel better? Definitely. God bless her soul. Also, kidney stones. Certain calcium salts and magnesium salts can exceed their solubility limit in urine. Of course, there may be a genetic predisposition.
Hmm.
Supersaturation can create crystal growth, and hydration lowers iron concentration, so proper hydration is necessary. I have a good friend, his name is Peter. Peter is 73 years young. I wanted to get him to be the face of Dreher beer because no one I know has ever had as many Dreher beers as he did. He was refused. Do you know why?
No.
He looks like an old alcoholic. Do you know why he looks like an old alcoholic? Because
Because
he
he's one.
is. Yes, yes, exactly. He's one of the kindest people you've ever met. He's lovable, but he's not particularly a good father, and that's a huge minus.
Yeah.
Yeah, it happens. It happens. He still has 18 beers a day. He works like as a security guard, and when he has to work, he doesn't drink. And he
Mm-hmm.
just uses his pension and his wages in order to fuel his drinking. He has a lot of beer. He had kidney stones when he was younger. And
Mm-hmm.
when he was younger, that was the 70s, 80s. It was sound medical advice at the time. Oh, drink up. Oh, sir, but I don't like the flavor of drinking water and whatnot. Mind you, Budapest drinking water was good at the time. Budapest drinking water was usually very good quality. The
Okay.
piping obviously isn't that good because time has passed. But yeah, by the way, God bless your heart. Uh, since I've put that water filter in the shower, my wife's skin and hair has
Yay.
improved dramatically. That's amazing.
Perfect.
First piece of medical advice I got, my God. And of course, kidney stones may form when you don't drink up. And well, his solution was to drink enough beer,
Mm-hmm.
because when he was younger, he was diagnosed with small kidney stones. In Hungarian, we use kidney stones for bigger crystals, and we use kidney sand for smaller crystals
Okay.
as a term. Vese-homok, vesekő. It
Mm-hmm.
is just really strange, but it is what it is.
Okay.
And usually oxalate crystals and urate crystals and a number of other crystals may be at work here. Uh, Usually oxalate crystals are the most common, calcium oxalate.
Mm-hmm.
Now, what contributes to that? Low levels of hydration, uh, too much calcium, of course, and too much oxalate from metabolites. If you, let's say, eat more than 2 grams of vitamin C a day, which can only come from supplementation because it's insanely impossible to have that much of it from food, there's a higher risk of developing calcium oxalate crystals. These oxalate crystals are in the shape of little caskets, and those little caskets can hurt when they leave the body. Uh, Obviously, if you drink up, if you exercise, and if you don't overindulge in anything, it should not happen.
Hmm.
Do you know sorrel? Sorrel in Hungarian, shushka. You probably
Okay.
ate it as a sauce,
Yes.
right?
Hmm. Yeah.
Usually it's prepared with milk, right?
Yes.
Why? Because folk cuisine knows better. Milk basically reacts with the oxalic acid and forms calcium oxalate that doesn't get absorbed into your body. However, if you would eat it raw or if you would eat kale raw in high amounts, like 500 grams or more a day, that can increase the risk of kidney stones. I'm not saying it causes it, but it dramatically increases the risk of kidney stones
Okay.
because if oxalate is present and calcium is present, a precipitate is much more likely to form.
Okay.
Now, I usually drink up. I take creatine and I go through at least 2 to 4 liters of water a day. And it's good because even when you're on a break, it helps your soul and your mind as well. Because instead of engaging in gossip in a teacher's room, you're going to be urinating. And believe me, it's far more pleasant than listening to someone's political opinion or gossip on who they hate. You can learn from everybody. Even though some people are only good as bad examples, it's still a powerful lesson to people who are able to think. Yes,
Yes.
I mean, you drink up, you take good care of yourself. Biological fluids, blood, urine, and the cytosol do contain many dissolved ions. And also, there are certain fruits that can also eat you and hurt you. For example, if you eat too much pineapple, it can start eating into your gums and into your mouth.
Oh,
If you eat a lot of it, the enzymes are going to start breaking down the membranes. Or kiwi. Have you ever had too much kiwi?
I don't think so.
It has oxalate crystals in it and also an enzyme that is able to break down flesh. Of course, in the stomach, the acid attacks it and then you have no more issues. But
Hmm.
if you overindulge, well, you're in for a surprise.
Hmm.
Yeah, I found out the hard way and I was
Oh
like,
no.
oh,
Okay.
lots of dietary fiber in kiwi. Let's go for it. And when I had the third one, I was like, I never had this many. And I'm like, ow. It has tiny, tiny oxalate, calcium oxalate crystals
Hmm.
that can micropuncture your gums. It's not that bad if you don't eat too much. It's not too bad, and also enzymes that eat into you. So it's really heavy metal. Yeah, both pineapples and kiwis, you're eating them, but they're eating you. Ha ha!
Hmm.
And of course, these are complex ionic environments, so it does help kiwi maintain its shape, and it's a great source of fiber. Just don't go into excess. That's the bottom line here. Drugs and
Yes.
salts, their absorption and their formulation depend on solubility. Sometimes solubility and absorption is pretty much influenced by how soluble they are, how fast they become available. When I was dissolving my creatine here, I have a lot of muscle men nearby, physio therapy students, absolutely stunning young men and women, and they were like, "Oh, it must be good quality creatine. It dissolves so well in water." I'm like, "No, it's not the quality, it's how you dissolve it. You want to dissolve, yeah, let's say 7 grams in a cup of water. It will never work. If the water is cold, yeah, and the solubility, let's say, is 7 grams in 500 milliliters at 18 degrees. If you lower the temperature, solubility decreases. If you lower the available volume, obviously you're going to have solids left over. And when you drink those solids, first of all, it's unpleasant to drink the powder. And second of all, it can irritate the lining of your stomach if it remains a solid.
Mm-hmm.
However, I have a 700 ml flask. I fill it with 4-degree water and I add 4 grams of creatine monohydrate to it. It dissolves like powdered sugar. It's not the quality of the creatine because it's from, I don't know, Volt, because I needed it. And I
Mm-hmm.
have like half a kilo laying around, but I always put it in little receptacles so it looks like cocaine because it's fun, yeah. But putting silliness aside, bioavailability and absorption is going to be much more better if you dissolve it completely. And when we learned about this, they really appreciated it. A lot of boys supplement with creatine, and a lot of people who don't have enough sleep, they do supplement with creatine, and it helps you use ATP more efficiently. I'm not saying that it's magic, because nothing's magic, but it's really, really helpful. And of course, in laboratory conditions, we have to predict if precipitates form. We have to write up ionic equations because obviously, in certain chemical reactions where precipitates form, we have to be able to predict how much does it form, how likely is it that it will form, what can I do to precipitate absolutely everything from a solution. You had to make these extracts, you make these alcoholic extracts. However, if you want to make sure that, let's say, you want to extract something into an organic phase, but it's also water soluble, you're going
Mm-hmm.
to add a little bit of a strong electrolyte to the aqueous phase and then use a separatory funnel in order to make sure that all of the organic substance goes into the organic solvent because there's a mild solubility in water, great. However, most of it, it's going to go into the organic phase.
Mm-hmm.
It's an art form. It's an art form. Here are the appropriate books. Obviously, I like to include those because years of experience. Whenever I would talk about a topic, there will always be a highly decorative and wearing a lot of makeup, a Persian kid going like usually a lady. Excuse me, which page? Because they wanted to follow along in the book.
Uh-huh.
Um, they're much more used to going always by the book and not too much used to taking notes.
Mm-hmm.
What does prepared mean? Because oftentimes I would feel when I was a student that I was ready for this topic. Well, we have to be able to define clearly, predict correctly, write equations, calculate quantitatively, and defend medically relevant reasoning. Will this form kidney stones? Excuse me, just a moment. Has she? Ah, there's someone knocking at the door. Just a moment.
Okay.
Yep. I have class now. Email me, okay? Is it urgent? What's wrong? Yeah? Yeah? Yeah. It takes time. Yeah, it's not up to me. It's not like I'm going to write a letter and that's it. These have their own thing. Yeah. Oh, it can take around a few months, so it's fine. Excuse me. I have a class now. I have to go back. We will do everything in our power to help you. Okay, don't worry, but these things take a few months for everybody. You apply now, and at the end of the semester, the credit is accepted. When I get the paper and I can accept it, I'll do it. But I cannot do it on my own. Okay? God bless you, kids. God bless you. Poor kids. Those kids shitless. They did physiology last year, and they
Mm-hmm.
needed the credits accepted. And they're Persian papas, of course. And they
Mm-hmm.
know they can get shit done with me. I'm all for them. I love them dearly. They're like my pets. Seriously, they're like my cats at home, practically my bros. However, it's not like I fill out a piece of paper and you know what, boys, we're done. No, there's a way of doing things and it's bureaucracy and I hate it, but I can't really go around it because I will get into trouble as well.
Mm-hmm.
They're delightful boys. They went from optometry to nursing. They're going to be good at both. It doesn't matter. Yeah, yeah, they're good kids. They said they applied 5 days ago, and why wasn't there any response? I said, oh my God, dude, I haven't received anything of it because when I receive something, I react to it as quick as possible.
Uh-huh.
Ions. Sometimes sodium chloride doesn't dissolve in water. Why? Why doesn't sometimes salt dissolve in water?
Maybe due to the temperature or the
Temperature
amount,
and
the amount of salt in the water. Maybe it's like oversaturated or over.
exactly. If it's oversaturated, it won't dissolve anymore. A 40% solution can be saturated. A saturated solution of sodium chloride is called a brine in English. Have you heard the term brine?
Brine, yes.
Brining something. Usually they brine meats. They brine them to soften them. And not just to soften them, but to change the characteristic of the cut of meat. It gets seasoned, and the strong electrolyte denatures the proteins and doesn't allow bacterial growth. Then they pat it dry, pop it in an oven, bam, turns into something next level.
Mm-hmm.
And the cut itself gets enough salt absorbed that it's going to turn into something out of this world, something fantastic. Yes, that's the whole deal with brining. It's a complex thing because
Mm-hmm.
ions do get exchanged, yeah, and salt preserves various cuts of meat. Balanced equations, basically, they're very important because it's the language of chemistry.
Mm-hmm.
There are going to be a couple of stoichiometric coefficients here. We're going to talk about those as well. Molarity is also going to be fairly important. We already talked about concentrations, osmolarity, and whatnot. And I've seen you understood that quite a bit.
Yes.
Uh, Dilution is very important. Once you've mixed things, obviously you add more water, the concentration drops. Yeah.
Mm-hmm.
Equilibrium is a very important thing here as well, because you said when we increase temperature, obviously solubility of certain solids may increase. Spot on, perfect.
Mm-hmm.
In the case of gases, it's going to be the reverse. You increase temperature, and gases are not going to be as soluble in water.
Mm-hmm.
Hydrogen sulfide has a certain solubility in water as well. It's not just carbon dioxide. Carbon dioxide reacts with water, forming carbonic acid, and it's a weak acid that can decompose in your stomach and it will exit your body some way.
Mm-hmm.
It will find its way. Hydrogen sulfide, on the other hand, smells. Have you ever been to places where water contains hydrogen sulfide?
I have no idea.
Usually it smells, so you would remember. In seafood, there are places that have these kinds of springs, and people drink that water as well.
Mm-hmm.
And it stinks, but it has beneficial effects on the gastrointestinal tract, and it helps you build up a better gut microbiome. It's odd, isn't it? And you can actually buy certain mineral waters in Hungary that you open it and everyone's like, ew, what was that? The hydrogen sulfide and sulfur containing compounds on the inside, they can be rather beneficial. And you don't want to boil this water because the hydrogen sulfide's going to escape and it's going to make the room smell bad.
Mm-hmm.
It's a bit odd because in huge amounts, hydrogen sulfide is toxic. In small amounts, it has medical benefits. So again, concentration means if it's medical or toxic. And the Le Chatelier principle means that systems are at a certain equilibrium.
Mm-hmm.
Certain mistakes may come up. We're going to talk about that. An ionic solid is going to dissolve in water, and obviously the ions are going to get hydrated.
Mhm.
Hydration is the water-specific solvation of things because
Yes.
fat, let's say from my shirt, by the way, I haven't had accidents in a while. That means more than 24 hours, yes. I love white shirt, but I also love Chinese food. So yeah, I think we're in for a bib or something. That's super unpleasant when you're clumsy. And the thing is, it's best to use chopsticks. When you use a fork, you're going to start dropping things. Yeah. Do you know why the Chinese use chopsticks?
I don't know. No.
Well, they were poor. Well, everyone was poor, but they had a particular shortage of fuel.
Okay.
So when they had to cook food, they had to chop it up in small pieces because it's going to be ready much quicker. You
Mm-hmm.
could just light a bit of hay on fire and you would create a large flame, and that would cook your meal quickly. But obviously, if they wanted to try it, it was very hot. So they started poking it with a stick and basically just getting it on skewers. And then they discovered, oh, if you hold the two of them together, you can pretty much fish out the small bits of food. And yeah, that's how chopsticks became a thing.
Oh,
And
uh-huh.
the other thing was if you cut food in small pieces, you didn't need to carry a knife or any kind of weapon. So
Mhm.
when you went to a noble banquet, everyone could surrender their weapons, even small knives, and the likelihood of mortal aggression was greatly reduced.
Uh-huh. Okay.
Yeah, it's
Interesting.
interesting. Yes, yes. And it's pretty odd how they have discovered a number of things as well. For example, certain salts, when they dissolve, they cool down the solution.
Mm-hmm.
For example, nitrate salts, they so endothermic that they can create ice. In a pot, you add some kind of nitrate, and in that nitrate and water solution, you have another pot with water, and you can create ice. And it was an ancient way of creating ice, and the Chinese discovered that as well. It is just insane what these guys wouldn't do. They also made penicillin. They just didn't know it was penicillin. They just knew it was medicinal and it was good against infection.
Uh-huh. Huh. Interesting.
Yeah, I studied all sorts of folk remedies, and here in the Carpathian Basin as well. In days before these wars and wars of independence and wars of whatever, people actually knew more about nature and how to heal themselves. I'm not
Uh-huh.
saying they were experts or doctors or better than today, no, not at all. But yeah, the narrative of the day always condemns the previous times instead of actually learning the good parts and letting go of the bad ones.
Uh-huh.
Don't toss out everything. That's my policy. KSP is the ion product of the saturation of a sparingly soluble salt. Sparingly soluble. That's such a good impression, sparingly.
Yeah.
It doesn't dissolve that well, but in analytical chemistry, I would probably call it a precipitate.
Uh-huh.
And QSP basically says the current solution. It hasn't really reached equilibrium yet, but it's getting there.
Mm-hmm.
I'm adding one reagent to the other dropwise, and it's going to create a precipitate. You probably have done these reactions or seen them on video.
Mm-hmm.
You have chlorine in water. I mean, I would just do it with tap water and add gradually silver nitrate to it, and I'd be like, let's see how much chlorine is in this water, and it
Mm-hmm.
would always precipitate quite a bit. I mean, obviously, chlorine has a certain solubility as well, but chlorinated water usually would have a foul odor
Mm-hmm.
and a bitter taste, which kids really disliked.
Mm-hmm.
And we didn't have water filter technology at the time. Nowadays, it's much better. And it's not because of ideologies, it's because people wanted it, needed it, and made it.
Mm-hmm.
Yeah, when China became more capitalist, there you go. Uh, so what happens is I start adding silver nitrate, and silver nitrate, and of course any kind of chloride react, and white precipitate forms in the form of silver chloride, right?
Uh-huh.
And the silver chloride is going to appear as something murky at lower concentrations. You feel like it's gonna reach equilibrium soon. That's when we can talk of a QSP. Basically, it's going to be the ion product of the ions present, and when it reaches a certain threshold, bam! All of a sudden, you're able to see that a white cottage cheese-like precipitate appeared, and it's moving downwards, and that's a positive test for chloride ions.
Uh-huh. Okay.
When we started analytical chemistry, we started with precipitating certain ion families. Everybody got two ions. Me, I got five because the teacher hated my guts because I would correct her. And I had to stay in a 5 more minutes in the lab because I didn't find all the ions, and she was like, either I find them all or I have to redo the semester. I found them all
What?
and said goodbye. No, it was okay. I mean, I'm an associate professor. She's still a teaching assistant, so
Uh-huh. Damn.
yeah, she's a good mother, not necessarily a good person, but some people don't like to be corrected by their students. I love to be corrected by my students. Do you
Mm-hmm.
know how good it feels? It's not like you're challenging my authority. No, you're paying attention. You're being smart. I love that.
Mm-hmm. Okay.
I don't mean it as an no, no, it's the best feeling ever. I mean, when you plant a tree and it grows taller than you, that was the whole goal. You want to
Mm-hmm.
be in its shade. Well, same thing is when you're educating younger people. Yes.
Mm-hmm.
Then I met up with my friend from the Peace Corps because we wanted to start recycling in Kolozsvár, and it became a lucrative business, by the way, because we joined the EU, and yeah, if you're open to new experiences, you're going to meet incredible people. I also
Uh-huh.
met Obama before he started running for office.
Oh, yeah,
He worked for
you
the
told me
Peace
that
Corps.
last time. Yeah.
Yeah, yeah. He was the first black guy I've seen in person, and I told him that. And he couldn't
Mm.
stop laughing. He was like, "What the hell?" I said, "Dude, we pick our own potatoes. We didn't need slaves here, you
And
know."
where did you meet him?
In Kolozsvár.
In Kolozsvár. And why? What
Oh,
was his name?
the Peace Corps had some kind of a get together, some kind of a diplomatic event. And they also
Okay.
invited me and a couple of other students who had an environmental service club. It was totally about not having recyclable items thrown in the garbage, but actually having them recycled. And it became a
Uh-huh.
huge thing ever since. South Press makes a lot of money from recycling since then because they noticed this is a good raw material. And yeah, before that, everything went to the landfill. And it
Mm-hmm.
was a good initiative. And actually, the guy in charge, the CEO of the company, he has a knack for making money even out of trash. And a lot of people envy him. He's like, Janos, he makes money out of trash. Yes,
Mm.
as he should, as he should.
Uh-huh. Okay. That's cool.
Yeah, I got involved with this because I've met an American guy because we were always walking home by foot in order to be able to stay fit. And that's how we met. And we started talking, and the one thing led to the other. It's all about being open to new experiences, you see. Because
Uh-huh.
others would not really talk to him because he was an American. Don't ask, stupid Balkan mentality, you know. It's like a couple of monkeys sitting on a tree staring.
Uh-huh.
I hate that. I hate that so much. And I would rather go there and shake hands and, hey, what you doing?
Uh-huh.
Because
Yeah, of course.
it sucks when you feel excluded. And yeah, he learned basic Romanian, basic Hungarian, got married, got two dogs, went back to the US because he had some kind of a gap year or something, and he wanted to travel to Europe. And I was like, why Romania? Of all places. He would also hitchhike, and my dad picked him up a few times.
Uh-huh.
And having an American there was such a unique thing that everyone called him the American. I'm like, dude, how Balkan are you from a scale of 1 to 10? And my dad was like, I've met your American too. I'm like, dude, his name is Kyle, okay? He has a name. Call him Kyle, not the American. Yeah, he's a great dude. Got married, has children, lives in Montana. Yeah, he's okay. He's a swell guy. He's a swell guy, and he was doing this because he really believed that he's doing a change, and he was actually bringing about
Uh-huh.
positive change. It wasn't about virtue signaling or anything. We would sort trash through trash cans. It wasn't like he had any issues getting his hands dirty. He wasn't a limousine liberal. He was actually doing things with his hand, leading by example, and I really like that about him.
Mm-hmm.
He taught me to go there and talk to the guy in charge because you can reach out to anyone. Worst thing they can say is no,
Mm-hmm.
and he's right, and he's right. Yeah. Why am I telling you this? Don't be afraid of anyone. Everyone's a human being, and being an adult is overrated. No one has everything figured out. People just have more experience and basically far more many failures to show for than you
Yeah.
do. That's it. That's it.
Mm-hmm.
Seriously. Now, in biology, this is very important because of kidney stones, but not just kidney stones. When you have a common ion, obviously the common ion is going to push everything towards precipitation. And these ionic equations are going to show us what's about to happen.
Mm-hmm.
The KSP logic is going to justify the conclusion. There you have a white precipitate being formed. Uh, Obviously, diluted ion concentrations are very important versus volume. However, the precipitate, mind you, is never part of the solution. Even though it's there inside the cup, if it's no longer ionized, if it's a solid, it's no longer part of the solution. You cannot calculate its concentration and you cannot make it part of the solution. Usually when a precipitate forms, it means that the ion itself is in smaller amount in
Mm-hmm.
the solution and it's in constant equilibrium. Some parts get dissolved, other parts precipitate.
Mm-hmm.
If this happens at the same rate, we can talk about a KSP value at a certain temperature and a certain pressure. Because if I add pressure to a gas, more of it gets dissolved,
Mm-hmm.
following Henry's law. But if I increase the temperature, in the case of most solids, more of it is going to get dissolved.
Mm-hmm.
There's always a chemical conclusion. It may be visible. A precipitate forms. There's no precipitate. The system is saturated.
Mm-hmm.
Stoichiometry plays an important role here as well. Now, solubility is obviously a physical property because if I dissolve something in water, its chemical characteristics don't change. If I evaporate the water, I get back the same compound. Be it sugar, be it salt, be it anything else. KSP is the solubility product, and QSP is the current ion product calculated from actual concentration at a given moment, but not at equilibrium. Not at equilibrium. Molar solubility tells you how many moles can be dissolved in that volume, and the common ion effect decreases the solubility caused by adding an ion already in present in the solution. So you increase the concentration of a common ion, hence the less soluble compound is going to precipitate, or or if it's not about precipitation, if it's about extraction, it is more likely to enter the organic phase if it's also soluble in the aqueous phase and also soluble in the other phase. A spectator ion is an ion that doesn't play ball. Yes, it's an ion present in the solution that does not participate in the net chemical change. In a football game, obviously you have the spectators and you have the players. Well, this is a spectator. Sorry for the football analogies. I got quite used to it whenever I had to explain something to my dad or my peers. I had to go back to football. I don't even like it that much. My wife really loves it. She used to be a referee.
Your wife used to be a referee?
Yeah, a football
Oh, okay.
referee. Yeah, and she used to play women's football as well. Yeah.
Oh, that's
I
cool.
mean, here it's called football. In America, it's called soccer. I mean, when she was 17, when she would give a yellow card or a red card to a 40-year-old, he was afraid of physical violence oftentimes. Because in the countryside, in Sekeford, some people tend to be rather, um, how to say this, not that well behaved, and they don't really exercise such emotional self-control, nor abstinence from alcohol back in the day, if you know what I mean.
Hmm.
And don't get me wrong, I mean, I don't hate people for being addicted to things because I have learned, for example, that people who turn into alcoholics, they're remarkably good problem solvers. But when you don't have enough problems, you turn to some bullshit like constant drinking, and it's a ruin. It's a ruin. I try to avoid the excessive drinking, or we don't drink much because we had a few folks like that in our family as well, and not great, not great. And yeah, oftentimes we smile about certain things, but we shouldn't because it's bad. And yeah, once you draw the line, then you don't pass on this generational BS, and the next generation turns into something wonderful. I see that with the little guy. He's like everything's cool. Some things are highly soluble. I add a few crystals of salt to water, whoosh, disappears. If it's fine salt, it dissolves immediately. If it's huge clumps of salt, will it dissolve as easily? Or
No,
it doesn't have to be salt, it can be sugar.
no, it won't.
Think about, have you ever had saffron sugar, by the way? Are you allowed to have saffron?
I'm not sure. I think so.
Okay, just asking for a friend, because I'm involved with Iranians and they bring me all the saffron in the world and good saffron, the Iranian saffron, the one you can smell over the room. You know, it's like good marijuana. You can smell it over the room. Or as my friend says, bad woman. You can smell her over the room as well. Some compounds are sparingly soluble, like calcium sulfate, gypsum. They don't use gypsum much anymore, only in cheaper casts nowadays. Better casts have 3D printed structure to them, but it used to be used in order to make these casts together with other compounds as well. And the sparing solubility, when it dried, it became a shell, and it would maintain the position of a broken limb. And practically insoluble means that its solubility is so low that it's not significant. I mean, there's no such thing as insoluble per se, because everything is soluble, but it's just soluble in so small amounts that what are we going to do? 10 to the minus 6 is 1 per million. 10 to the minus 10, even less. What
Mm.
does that matter? The crystal level breaks up, water approaches, it hydrates these compounds. Obviously, in the case of chlorine, the hydrogen part's going to be towards the chlorine. In the case of sodium, the oxygen part is going to be towards the sodium plus. And this is how salt can draw water, and we've talked about correlative properties, how boiling point increases, how melting point decreases, and dissolution and hydration occurs at the same time. Dissolution requires energy, hydration releases energy. The hydration energy is bigger than the dissolution energy. It's going to be an exothermic process. If the dissolution energy is big, and the hydration energy is smaller, then it's going to be an endothermic. So this is why when you add salt to ice,
Mhm.
it will severely decrease the temperature of ice. Uh, when we're going to talk about thermodynamics, I think I'm going to carry out that experiment over a webcam, and I also have a thermal camera. So yeah, I have several thermal cameras. Jeez, you know why? to demonstrate these experiments. And also, if a building isn't properly insulated, well, that can be a huge issue as well.
Mm-hmm.
And oftentimes this is a great way to detect it. Or if it's winter and someone releases a gas cloud, you can see it with thermal imaging.
Mm-hmm.
It's pretty funny. In humans and in cats as well. Dissociation occurs when you have an ionic compound and it becomes ions, and hydration is basically as the solvent encircles these ions. Water is polar, cations attract oxygen, anions attract hydrogen, somewhat. And there's going to be an ion dipole stabilization. So each and every ion is going to have a layer of water around it. It's called a hydrate layer. In Hungarian, it's called hidrátburok. Why am I saying this? Because I've learned an archaic Hungarian scientific language that doesn't apply to Budapest people. So I'm trying to get you ready for such things. Lattice attraction oftentimes comes from ionic bonding,
Mm-hmm.
right? And that ionic bonding, well, it's a pretty strong thing to break. Sometimes it's stronger, sometimes it's weaker. For example, if I would want to dissolve sodium hydroxide or potassium hydroxide, I should do it in a larger volume of water and add the hydroxide to the water because it's a highly exothermic process. If I want to dissolve acid, I'm supposed to add the acid to the bigger volume of water dropwise while stirring because sulfuric acid, for example, its dissolution can be highly exothermic. If I would do it the other way around, if I would add a concentrated acid, a few droplets of water, what would happen is that due to the exothermic nature of the dissolution process, the water would boil over. And if it boils over, immediately starts spitting acid in every direction. So we have to be very careful about how we dissolve very concentrated alkali and acid. I had a colleague in chemical engineering. We called him Bunker after an incident. Bunker was told to create a 1 molar sulfuric acid solution for laboratory purposes. We needed a milliliter of it. What Bunker did is he took the 5-liter canister, put it under the tap, and then released water into it. Guess what happened?
Mm, I don't know.
An extremely exothermic process occurred.
Okay.
Immediately, the bottle shattered into a million pieces,
Mm-hmm.
and sulfuric acid spread everywhere. Nobody got hurt. When I heard the explosion, I ran. They told me what happened. We immediately wiped off Bunker. We basically cut the clothes off of him. He remained in underpants, and his clothes and shoes dissolved in front of us. We had to exit the laboratory, and well, yeah, next week he had to clean everything up, pay for damages, and of course. He almost got kicked out of university. He became a theoretical chemist, and he basically works in a theoretical field. He makes reactors. He's very good at IT, but he's clumsy in a laboratory. And we gave him the name Bunker because when you're working with him, you don't need safety equipment. You need a bunker. Stay safe. It stuck with him. His
Mm-hmm.
mother calls him Bunker. His wife calls him Bunker. His son calls him Bunker too. We love him dearly. He made one mistake. It's like in the military, it stuck with him. And
Well,
oddly enough, he hated Hungarians when he came to Kolozsvár because he's Romanian. His name is Ciprian. He started loving Hungarians after he had seen that we cut the clothes off of him and we made sure he wouldn't get hurt. He's one of the luckiest bastards I know. Most people involved with strong acid and strong bases, they had their fair share of issues, and thank God he's all right. Yeah. But I'm telling my students these stories because they're very informative, and it's very important that you carry this with you because you may have a bunker in your own group. When you choose a life partner, choose wisely. Um, no, seriously, it's even better than you would choose a life partner because you can divorce a life partner maybe. Hopefully you don't have to, I mean, obviously,
Uh-huh.
but with a life partner you might get stuck for a long time, so choose wisely.
Okay, I'll keep that in mind.
No, no, it's very important. Uh,
Mhm.
Silver chloride, a classical precipitate, and insoluble means not zero but very low solubility. Saturation, we've already talked about this. We've talked about brine. We've talked about how important it is in the detection of chloride ions that silver chloride forms a white precipitate. Static appearance doesn't mean there's no chemistry. There's constant equilibrium. There's dissolution, there's precipitation happening at the same rate. There's dissolving, there's recrystallization. So always
Mhm.
consider it an equilibrium reaction. In an unsaturated solution, obviously you can dissolve more. In a saturated solution, you can't dissolve anymore. And a supersaturated solution forms when you've heated the solution, you dissolve more, but as the temperature drops, KSP value drops with it.
Mhm.
Unless you do something to it, it may remain supersaturated, but you touch it. You start playing a violin next to it, it will form a solid, it will precipitate.
Mhm.
Or you can just, I don't know, you can just put a glass rod into the solution and a precipitate will form in a supersaturated solution. It is remarkably beautiful. Oftentimes, supersaturated solutions of sodium acetate are played with. In a supersaturated solution, as I said, a little bit of tinkering is going to cause precipitation. This is something we want to avoid in kidneys. We want to avoid these kinds of triggers. And if conditions change, yeah, supercooled solutions. Oftentimes they do remain a liquid, but as soon as you pour them out, they start solidifying.
Mhm.
Some people did that with beer, and they poured it out and it turned into beer ice.
Huh.
I'm like,
Interesting.
wow,
Okay.
I did that with Monster Rehab Lemon.
Of course.
Yeah. What, but what else have I got?
Obviously.
Obviously. Oh, yes. Uh, no, before yesterday, I had two big black bags, and one of the paramedics was like, "What's going on, sir? Are you throwing out the anti-monster cans?" That wasn't the case, but it hit home. I was laughing for 10 minutes straight. I love those kids. So proud of them. They're so good kids. Now, obviously, you want to avoid crystal formation in your kidneys while passing a kidney stone hurts like hell. The guy who came up with the isolation of morphine from dried poppy, Caballano, she had a kidney stone. He got 2 doses of morphine. It hurt so much.
Mhm. Hmm.
Temperature influences the solubility of most solids, not all of them, but most solids. The positive when in the case of gases, as I increase the temperature, solubility gets reduced. Have you ever tasted boiled water? Why
No.
would you?
I mean, probably because of tea.
Oh, yes, yes. Actually, the Chinese invented tea because they didn't have drinkable water, because oftentimes it would be cross-contaminated with random things, so they had to boil it. But in order to make it more flavorful, they added herbs to it, and tea was born. Because boiled
Uh-huh.
water on its own doesn't taste good. Water tastes good if it has enough gases dissolved in it. Not fizzy necessarily, but it needs to have oxygen, nitrogen, and a couple of gases, so you feel like it quenches your thirst. gas, poor water doesn't taste right. It's like it's stale. It's not good. I'm gonna throw it out and pour myself a new cup. That's why a lot of people in Europe really love carbonated water and carbonated beverages. It hits
Hmm.
different, especially if it's cold.
Yes.
Now, obviously, classifying solutions, no biggie. And from if for a salt solution QSP is larger than KSP, what does that mean? It is supersaturated, and as the temperature drops, I'm going to have crystal formation. This
Hmm.
has happened to me in organic synthesis. One of the first compounds I synthesized was N-methylphenothiazine, and it was an oily substance. And I told my supervisor, "Sir, it's really not doing anything." And as I said that, it made a crack. I almost dropped it. I got so scared. It turned into needle-like crystals because I was shaking it a bit, and I'm like, "Sir, it's not doing anything." And as I said that, it went like, and it made a crack, and it was so surprising that all of it self-organized immediately
Hmm.
into lovely needle-like white crystals with a perfect melting point, boiling point, NMR spectrum, elemental analysis, and everything. It was perfect, and I was so proud of it.
Hmm.
Yeah, I wanted to cover a few crystals in lacquer and preserve it, but they said it's not necessary. It's enough to photograph it.
Hmm.
Yes, it's a wonderful experience, and you can do that with a number of inorganic compounds, such as sodium acetate, or oftentimes you can grow beautiful crystals with copper sulfate. Copper sulfate is going to be blue. Just careful. Uh, I mean, obviously, you're not going to taste things, but I have an electric lighter. It creates a plasma. My students wanted to see. Girls, they just looked at the arc and that was it. Boys, what do you think they did? They
They
started
probably want
extending their,
to, yeah.
yes, yes, they started extending their tongues, and I'm like, I want it back.
That
Exactly.
happened in our school as well when the teacher gives us something that I mean we could possibly taste, but it wouldn't be good for us. They want to taste it immediately.
Yeah, 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 yeah. I have a friend and colleague at BME. He's also Laszlo. And my friend and colleague at the time, Kolosh, was like, "Sir, I remember when you handed out the blue salt, I tasted it." Laszlo comes closer to me. He's like, "There's always an idiot like that in every year. Tell your friend." I'm like, "Dude, he's my colleague. We're not that close." Just got so fed up with this tell your friend. He's a grown man. He's 2 years older than me. He should know better. No, seriously, it's just weird when you're responsible for a research group. There's a leader of a research group, a professor. You're a PhD student or a postdoc, and you pretty much have to tell people who are your seniors to behave. It's odd.
Yeah.
You can pretty much predict why something will be more soluble than the other from these KSPs, but you won't be able to tell how much will dissolve. That is usually defined how many grams in how much water at what temperature. Usually that's how we
Mhm.
define solubility. So yes, it can provide the rapid entrance exam pattern recognition, and obviously, these are shortcuts, but they're not the whole picture. There are certain groups that are always going to be soluble. Nitrates are always going to be soluble. You have a lot about this in table form in the Stoker book. Alkali metal salts are usually soluble. Um, Uranium acetate can precipitate sodium, but that's such an exotic chemical that basically the whole term uranium is going to scare people away. It's not radioactive uranium, I promise. One
Mm-hmm.
of my friends well, he wasn't arrested. He was just questioned by the police. Why does he have uranium acetates? I'm like, you wonderful, extremely well-educated people at the police is there to precipitate sodium from blood. And as the color changes, you can use spectrophotometry to determine the sodium concentration in blood. That's what they use it for. And they were at all, but it has uranium in it. I'm like, yes, old glass has uranium in it. It's an alpha emitter. It won't affect you in any way because it's trapped in the glass. And this won't affect you either because it's non-radioactive and you're not going to eat it. You promise you're not going to eat it? Your level of silliness. Ammonium salts oftentimes are extremely soluble, quite hygroscopic in many cases. Ammonium chloride smells really pungent. In Hungarian, it's called salmiak só. Salmiak means ammonia containing.
Mm-hmm.
Salmiak says means it's dissolved in alcohol. That was also used to preserve sausages and salamis, and you could create summer sausage with that. My dad and I, we made there were these cheap summer salamis back at home. We made them into winter salamis by basically washing them off with this ammonia alcohol thing and leaving it in the wine cellar. And a white mold started growing on it. It was so uniquely incredible that I'm still trying to recreate it. I mean, pig winter salami has nothing on this because it has its own microbiome. The fungus itself exists only in my dad's wine cellar, which has only existed in his granddad's wine cellar, which only existed in his granddad's wine cellar. So we're carrying it on. It's gonna outlive us. But it's good. It's good for the wine as well because it's not just the mold, but also the type of the type of other fungi microbiome mixture thingy there, and they brought it from Italy at some point. In World War II, and before that, they've been there for some reason, and that's how they got it. It's a small world. Silver chloride is going to be a white precipitate, lead iodide. Uh, we call it aranyeső reakció in Hungarian. Golden shower may mean something naughty in English, so I'm not going to say that. Silver bromide has a different appearance, but you can't really say, oh, you know what? All chlorides, all bromides, all halogen salts are soluble. Silver, lead, and mercury, usually they may form porally soluble halides. And this is a great way to precipitate them and detect them, by the way. Many carbonates can remain solids, calcium carbonate, barium carbonate, magnesium carbonate. Certain phosphates may be very important and may not be soluble. Calcium phosphate connects directly to biological minerals. It creates a powerful solid inner shell. Um, Many hydroxides may be poorly soluble. Calcium, strontium, barium, and also magnesium hydroxide. That's why we have milk and magnesia. However, as you can see, a good chunk of them are fairly soluble. Iron hydroxide looks like a gel. Aluminium hydroxide also forms a gel-like substance with water. Can it be dissolved? Yes, yes. Sodium potassium tartarate can dissolve aluminum hydroxide quite well. However, in purifying organic compounds, oftentimes PhD students from certain unis, they're just going to use 5 liters of organic solvent just to wash out something stuck on aluminum hydroxide instead of using tartarate. Tartarate is basically the sodium potassium salt of tartaric acid. It's that simple. And it dissolves in water immediately. Oftentimes you have to detect ions. Back in the day, you would use reagents to detect ions. We used to have stinky rooms in the Department of Chemistry. Why was it called the stinky room? It's a word-by-word translation, Büdöszoba. Uh, yeah, actually it was called that. Um, because it had an atmosphere of hydrogen sulfide. Is that good? No, it stinks and it's poisonous. However, yeah, it's a fair warning sign. I stink. I'm poisonous. It's fairly easy to understand, right? But the funny thing is, it did precipitate a number of ions, and it was a great way to detect certain compounds because of the precipitation occurring. Nowadays, we have better analytical methods. We have automated machines that may detect these. Or if you want a home kit, oftentimes you can detect heavy metals and all sorts of compounds just with a strip. Just like for urine, there are these special strips for determining ions from drinking water to determine if the drinking water quality that you're getting is adequate. In Budapest, it is for cold water. For hot water, there's usually a boiler, and the boiler is not the freshest item in an apartment complex. So oftentimes, it may produce rust, which is going to obviously contribute to the buildup of special kinds of limescale. Does it mean that the water's bad or toxic? No, but don't cook with the hot water. Use the cold water for cooking, and once you're done washing dishes with hot water, wash them with cold water as well to get rid of these impurities that may be involved in the hot water.
Mhm.
That's what I can say about District 11 at LS Street. Why? Because those are the ones I've measured. I used the strips and I also took them to laboratory. It's good water, but you have to be careful. Yes,
Mhm.
a precipitation reaction is going to form a unique solid, and it's going to be a telltale sign that something's present here.
Mhm.
Molecular equations occur as such, and as you can see in parentheses, we're going to show the state of the matter. Do not stop at the molecular equation if the question is asking for a net ionic equation. As you can see, many ions here may be spectator ions. The only thing I'm interested in is silver, chloride, and silver chloride. Yes, so everything else is spectator because it remains inside the solution. This is the complete ionic equation, but you do have spectator ions being sodium, and spectator ions being the nitrate ion. So the net ionic equation would be just silver ions, chloride ions, and silver chloride. All the others, they are spectator ions. The net ionic equation basically drops what is unchanged in the solution, and what we're interested in is basically precipitation. And you have to name them, oh, which is the spectator ion, which is going to be the net ionic equation, and so on and so forth. Usually these exam questions, these multiple choice questions are interested in this. And why do we have this worked example so often? Because it's an essential reaction. It used to be an essential reaction in the detection of chloride ions. Nowadays, we have analytical methods, and we also have color changing strips that basically enable us to do that. We can oftentimes predict products. Barium chloride and sodium sulfate are going to form barium sulfate. Barium sulfate is used as a contrasting agent in gastrointestinal X-rays. Usually, you get a slurry of barium sulfate that you have to drink. Usually, it's flavored. My mom's friend, she had to undergo a stomach X-ray. She hates bananas. I think she's the only person I know who hates bananas. She received her drink of barium sulfate, drank it in one go, then made an awful face. My mom asked, "What's wrong? Did it taste bad?" She's like, "It tastes like bananas." Poor thing. She would have been okay with anything. It could have tasted like, I don't know, okra or absolute bitterness. It would have been much better for her. It was so strange. Barium sulfate as a precipitate is a good contrasting agent because X-rays do not penetrate it, and as it spreads out through the gastrointestinal tract, you're able to tell if there's any lacerations. And it's a cheap and easy way to see into the human body. Nowadays, we try to limit the exposure to most things, X-rays or even CT. CT may have an ill effect on cancer cells. So, yeah, we have to make sure that the investigations we are doing are non-invasive. There's a certain amount of X-rays you can have each year for a reason. You don't want to get a dose. Calcium chloride is also going to precipitate with sodium carbonate. Calcium carbonate is called limestone. In Hungarian, we call it mészkő. I come from a place where we have a mountain called Meseshegység. Even Romanians call it Meses because people have been living there forever, and it has a lot of limestone, and locals make a living from making charcoal and burning limestone at the same time. It's a wonderful place, full of caves, and it used to have wonderful wildlife. I'm not sure how much the European Union directives about environmental protection reach that area. I hope to God it does. When I was a child, it was lovely. And calcium carbonate, of course, is going to be a white precipitate, and oftentimes it's used in construction as well because of its relatively high hardness, not on its own, obviously. Now, obviously, we split the insoluble solids, and it's going to be kind of sort of an equilibrium reaction. And we have to make sure that everything that's ionic is in aqueous form, everything that isn't, it's going to remain in a solid form. We have to keep spectator ions. Obviously, don't lose the charges, make sure they're there. Don't ignore state symbols. That's something I will always do, not write the state of the matter and not write up the proper ionic equation. Why? Because for me it was obvious. Yeah, but for my examiner it wasn't. Thank God that in writing you're going to get only multiple choice questions. But in the first year, first you're going to have a test in order to earn the right to take the exam. Then in chemistry, there's going to be an oral exam, and it's going to have several parts. It's going to be a theoretical part, a practical part, a calculation part, and a problem-solving part. So we have to be prepared for that. Obviously, for you, it's not going to be that much of an issue. Now, do you have to learn the colors of the precipitate? Well, most of them are just white precipitates, as you can see. Lead iodide is the only yellow solid here. And as it forms, it looks like gold, kind of like fool's gold. Magnesium hydroxide is oftentimes used in milk of magnesia. Have you heard of milk of magnesia? Have you used it?
Mm, not sure.
Milk of magnesia usually is a cure for heartburn and for excessive stomach acid, but it's mainly used in the United States. I think in our culture here, uh, the folk remedy is sodium bicarbonate, but that can increase, of course, sodium levels. In more and more places, milk of magnesia has started appearing. It's a fine precipitate of magnesium hydroxide. You have to shake the bottle and immediately pour out a small cap of it, drink it, and then, of course, wash away whatever you used and recap it. And then the magnesium hydroxide reacts with hydrogen chloride and neutralizes the excess stomach acid. And obviously, you have to mind the amounts of magnesium you consume because extreme amounts of magnesium can excite the gastrointestinal lining and it may cause diarrhea. Mind your
Mm-hmm.
magnesium supplements. Mind the kind of magnesium you are using. And also with this potassium and magnesium statules, if they're puffed up, throw them away. If something has decomposed, don't use them. Uh, I'm talking about from experience again. Why is KSP so necessary? Because it tells you how soluble is or how insoluble that certain compound is that at that particular temperature. It's a bridge from probably insoluble to a numbers answer. Yeah.
Mm-hmm.
If it's 10 to the minus 6, 10 to the minus 9, a saturated solution is active but not finished. We've established that. However, these values are relatively low, and if you know if it's a low number, it's a precipitate. It's a precipitate, and obviously solubility is a number for both of them, and S square, it can be defined as S square, and the square root of KSP can be the partial solubility for one ion. Sometimes they ask this, sometimes they do not. It's not part of the Hungarian curriculum yet, but we're moving more and more towards Harvard style entrance exams, and I don't know what the entrance exam will be next year. So
Mm-hmm.
I'm trying to give you extra munition, just so you know this exists and it's not that difficult to calculate. You can
Okay.
mathematize absolutely everything. If you know what's going on, you can use stoichiometry, equilibrium, and apply it to the problem. Why? You're a smart kid. And believe me, a lot of your peers will fail at it miserably. However, the more ions I have, the more KSP relates differently. Because the more ions I have, the more ions I have to bring into solution, right?
Yes.
Magnesium hydroxide is going to have a sodium, the whole KSP is going to be 2s. In the case of aluminum hydroxide, it's going to be more. So there is a pattern. The more ions I have, the coefficient changes accordingly. Um, Calcium phosphate, again, its solubility is relatively low. It's important because in teeth, in bone, and in other places, it's going to be important. The proportion is going to be a 3:2 proportion. So obviously, same rule, just more stoichiometry here. And this plays a very important role in how osteoclasts and osteoblasts and osteocytes react to them because our bones are not just mere inorganic compounds. They're alive and they are changing through chemical equilibrium. Yes?
Mm.
Osteoclasts, they eat into the bone. Osteoblasts, they produce new bone. If you exercise, if you work out, let's say you do push-ups on your knuckles, the morphology and physiology of the bones in your knuckles and in your forearms and in your hands, they change dramatically. Have you ever seen Japanese practitioners of karate or other martial arts?
Probably. Yeah.
Their hands change. These old guys have hands like hammers. It's because of all the training. The body adapts to training. If you train, you're going to have higher bone density, higher muscle mass, and you're going to live longer. You don't have to do it excessively because it can cause injury. But if there's a proper equilibrium, you're going to be healthy. And I've seen you guys, you're lovely. I'm happy to see that you're happy and healthy, and that's what everyone should strive for. I mean, I'm talking with 120 plus kilos of whatever here, but we started working out with my son, and it's going to be insane. It's going to be huge. We'll be ripping apart phone books. Have you ever seen a phone book?
Yes, I have.
Yeah, wow. Who showed you who showed you one?
I think my grandma, some of my grandparents or great grandparents, I'm not sure.
Oh, yeah, we used to have these really thick books, and oftentimes they would tell us you don't have to learn the phone book. Uh, well, my friend and I, we competed at who can remember more from the phone book. So we still know where a couple of people live and what's their name and what was their landline number. It's not necessary nowadays because basically nobody has a landline anymore, or very rare occasions. Yes, some institutions may have it. But the equilibrium expression is very important because S connects the physical amount dissolves to the equilibrium expression, so shows you how poorly the something dissolves. That's the whole thing about it. And here's a one-on-one example with obviously silver chloride, which is a precipitate. It's a one-on-one type salt. And because we know the value of KSP, well, its square root is still a very small number.
Hmm.
10 to the minus 5 moles dissolved. That's 1 over 100,000. That's a very small number. That's something I would deliberately drink. You know, doesn't matter what it is. I mean, yeah, it maybe if it's Botox, then I might have some reservations, but I'm not sure. Now, why am I making these exaggerations? Because such low solubility virtually means that it's fairly unsoluble. Calcium fluoride is oftentimes in toothpaste,
Hmm.
right? Fluoride, why is it added? So the government can control our minds, obviously, right? Like it doesn't have Facebook or social media to do that, or the news, right? It's really funny when people say that certain things are being added so we're more easily controlled. Dude, we contribute to that by the things we consume. And we vote with our wallets and we vote with our behavior.
Hmm.
That's what we do. It's added there so we can have wonderful teeth. Have you noticed that usually Americans have good teeth?
Um, yes, but isn't it because they use those teeth whitening strips?
Is it? Oh, I think their water, the drinking water, is fluorinated since
Yeah.
childhood.
Okay.
Yeah, but here in the Carpathian Basin, it's really not that difficult because if you come from mountainous areas, obviously there's going to be higher levels of fluoride in the water. But for
Uh-huh.
example, people coming from the plains of Hungary, in the communist regime, small amounts of arsenic went into the ground and drinking water, not toxic, but since teeth absorbed arsenic, they were far more susceptible to decay.
Hmm.
Yeah, and also strontium may appear in teeth, according to the water you have consumed in your childhood. My son probably grew up in Borsig and Kékút at the same time,
Hmm.
because we didn't allow him to have drinking water from the tap. Why? Not like we don't trust it or anything, we just don't know what happens to it. And because he's a little boy, we wanted to make sure that everything was on par and of good quality. And yeah, maybe I'm a bit too worried and I test things too often, but yeah, I try to protect the little ones,
Hmm.
everyone. And obviously for equilibrium reactions, we use the ice method.
Iceland.
Sometimes sometimes I would call it the rice method because this is then
Hmm.
the but then I had Asians and oh, no, Asians were okay with it. Asians are racist to themselves, but certain people who are idiots, like you know how it is. Some people get offended on your behalf. I mean, I had people be offended on my behalf, and I'm like, I don't think I asked you to do that. And they would lecture me on how dare I not get offended on something that they were offended of, and I'm like, stop it. Let's just have a normal environment and a normal conversation because I don't get paid to get offended. And if someone came here to study, they didn't pay me to offend them. They paid me to give them knowledge. So it just pretty much went away. I don't think she works there anymore. Now, the Rice method, R is the reaction, I stands for initial concentrations, none of it, obviously, in the beginning, and of course, neither of it got dissolved. C is the change part. Obviously, it didn't change much, but some of it got dissolved, and at equilibrium, basically, what's left. It's basically a table being made to account for changes. And obviously, in the end, what we can state is that KSP is basically dependent on the concentration of the two ions at equilibrium. That's why it's called the ice method or the rice method, depending on which one you prefer to use. Um, both of them are great.
Mm-hmm.
Was I ever taught this method? No, I actually learned it from Andre. Andre was a little boy who wasn't particularly interested in chemistry, but since he wanted to prove himself to me that he's not a dumb kid, he started watching videos and he learned it from there. And he presented it in one of our classes. I was like, wow, we should probably use this. I would just use the ICE method, initial, during change, and at equilibrium, and he would add the R, so it remains more memorable. Well, ICE nowadays is an organization that some people like, some people hate. I'm like, dude, it's a police force. They're doing their job, not a business of mine. Milk of magnesia. How much magnesium is there in a solution of milk of magnesia? Well, definitely not much. Definitely not much. 10 to the minus 4, that's 1,000th of a mole, right?
Mm-hmm.
Very, very little. Aluminium hydroxide, again, extremely low solubility. It's not going to be something that's able to chemically burn me, right?
Mm-hmm.
If we have the molar solubility of this S given to us, we can easily calculate KSP. So it's basically playing around with math. Mass solubility, molar solubility is going to be compared. How many moles can be dissolved in a liter? How many grams can be dissolved in 100 grams of water? That kind of solubility gives you a very important um, set point because later on you'll be able to determine that, oh, table salt is going to be far more soluble, let's say, than calcium sulfate, for example. Calcium sulfate is going to remain a solid. Now, mind you, if there's no chemical reaction occurring between them, if they will remain spectated. It's a very important thing to use appropriate scientific notation. What kind of scientific calculator are you using?
Um, the Casio one. It's
Perfect,
yeah.
perfect. I've won one of those and my sister took it.
Why?
Because she was like, "Can I borrow it?" I said, "Yes." For me, it was a trophy. Then she was like, "Can I keep it?" I'm like, "Sure." I didn't need it. But yeah, it was kind of funny. Yeah, when you have younger siblings or people who in their character are like your younger siblings, you're like, it's okay. You're a plus one parent or a co-parent, so obviously you're going to be happy that they're happy and you're going to be happy that they progress and you just don't mind much. Yeah. Cube root and square root obviously produce different values. Obviously, a square root reduces the number less,
Mhm.
meaning that you get uh, different values, significantly different values. Yes, the
Uh-huh.
difference is tenfold between the two. So if you have, let's say, two kinds of solids with different KSP values and different amount of ions, you're able to compare between them and you're able to tell which one is more likely to precipitate more.
Mhm.
Yeah, it gives you really good material wisdom if you think about it.
Uh-huh.
Um, Revision oftentimes becomes memory. So if you actively solve these problems, you're in the safe. And KSP, QSP, they give you a good insight. We shouldn't confuse the two. Obviously, we've covered them, and QSP says what is it doing now, and KSP tells us until when. Yeah,
Mm-hmm.
so when it's changed, the other one equilibrium. This is where we stop if the temperature didn't change.
Mm-hmm.
It's very important. Unsaturated, saturated, supersaturated solutions are going to look like this. And
Mm-hmm.
from the values alone, you'll be able to tell in any multiple choice question. And of course, if you dilute something, what happens to concentration? They drop. Uh,
Drops. Yes.
Very good. Many people don't realize this. And you'd be surprised how many. Now, there are a couple of examples here. I don't want to take up too much of your time, but we will go over a few.
Okay.
But I'm gonna let you go. Let's say at around 12. Is that okay? Do
Okay.
you still have time? Can you still hold up?
Yeah,
Because
sure.
I don't want to overstay my welcome too much. Let's say no, because I know it can be really demanding. It requires brain power to follow along.
Yeah.
Yeah, yeah. So let me know if you need a bit of a break, you need to use the facilities or anything. It's not like a proper classroom class, it's just the two of us having a kind of dialogue.
Yeah. Mm-hmm.
We mix these two things. This is perfectly valid. This is something we would do in real life. We pour
Mm-hmm.
one cup into the other, bam, a precipitate formed. Now, we have to find the silver concentration in the solution after mixing, the chloride after mixing.
Mm-hmm.
And it's not asking anything about sodium or anything about nitrate. Yeah, have you observed that? Because we will account for that differently. In some of our entrance exams, such problems do not occur. That's more of an Olympiad question nowadays.
Mm-hmm.
Now, you can easily calculate from the amounts and the volume the amounts we have present. So the ion product QSP can be easily determined from there. We've determined the silver concentration. Has it dropped? Yes. Why? The volume doubles. Yes,
Mm-hmm.
the volume doubled. It became 100 milliliters. Same is true with chloride. From here, QSP can be determined. It's going to be 5 times 10 to the minus 5. Now, KSP has been given initially. Let's compare the two. Let's compare the two. QSP is 5 times 10 to the power of minus 5, which is how many times bigger than the KSP, which is 1.8 times 10 to the minus 10, 10 to the minus 5, 10 to the minus 10. How many
Double.
times is one bigger than the other?
Um, 5? No, it's double.
10 to the power of 5.
10 to the power of 5 and 10 to the power of 10. So then it's, well,
So the difference between them is 10 to the power of 5, right?
yeah, yeah, okay. That way. Yes.
And it's not going to be 5 times, it's going to be 100,000 times.
Mm-hmm.
Why? Because 10 to the power of 5 means
10
1,
times 10, mm-hmm.
1, 2, 3,
3, 4,
4,
5.
5.
Yes.
That's amazingly huge, which
Mm-hmm.
means silver chloride is definitely going to precipitate, which is what we expected.
Yes.
But yeah, if you don't have experience with these solutions, because why would you? I mean, I haven't done this experiment only when I was in second year of university. In high school, no, we didn't have much experiments. Or lead iodide, will it precipitate? Well, it depends on the QSP to KSP values. And in
Mm-hmm.
this case, no, no, because it's less. If it's less, no precipitate forms. You will have to wait for it to form as water evaporates. Then it reaches a critical concentration, and maybe some yellowish, murky thing is going to appear.
Mm-hmm.
Similar question with calcium fluoride. Calcium fluoride is how fluorescence got discovered. There was a guy, oddly enough, called Stoker, and he was experimenting with UV lights. And he started irradiating several things with it because basically F around and find out it's what scientists do. Uh, yeah, and that's how they make discoveries. And then they look for proper applications. And it turned out that calcium fluoride did show a remarkable thing. When you irradiate it with a black light means UV light. Yep. In American slang, they call it a black light for some reason. I don't know the reason for it, but yeah, and it gives off basically a different color because the electrons get excited. As they get excited, they get into a high energy state, but then they return. And as they return, they're going to emit a colorful light that we're able to see. Fluorescence is used in organic dyes as well, but calcium fluoride was the first compound where it was observed. Now, we mix 100 mils of calcium chloride with 50 mils of sodium fluoride in varying concentrations. Then at the end, obviously, we know the concentration of the various ions, and from there we can easily just calculate QSP or the reaction quotient and compare it to the equilibrium constant. Will it precipitate? Yes, because the reaction quotient is bigger than the other part. Now, obviously, how much will precipitate depends on stoichiometry again. If it's equal, then it's at equilibrium, it's at the threshold, it's very close. You add a crystal and bam. First trace of precipitate occurs here, and then when QSP increases, then more and more crystal is going to form, more and more solid is going to form, because oftentimes it's not a crystal, it's just a solid. Oftentimes in organic synthesis, organic chemists would call everything solid a crystal. That's not true. It needs to have a proper crystalline structure. Just because it's a powdered solid, it's not a crystal.
Mm-hmm.
Now, there's an algorithm here as well. This part is more or less for revision. I don't think you should be afraid of such questions because I don't think they're uh, that particularly difficult to you. But what is my